Okay, hopefully you can all see the screen. Let me know if you can. Welcome. We've got about 35 people online. That's great. Welcome to the webinar series that we continue with the International Building Performance Simulation of Association Australasia. My name is Quentin. I'm from Oricon. I'm the president recently elected of IBPSA Australasia. Just as a wee introduction to who we are, in case you're unaware, we are part of an international organisation that's all around the world that is all about encouraging, educating, bringing knowledge to the table, and being involved in events like this around the world. We have all sorts of associations and inputs into various other organisations like ERA, and obviously involved in things like Neighbours as well. We run conferences. We're actually looking at running a conference in a couple of years in Brisbane, so look out for that. And always keen for people to become members. So if you want to get involved in IBPSA, it's a very, very high cost. It's free. And you can go to our website there and get into becoming a member of IBPSA. So today we're here to talk about obviously future climate files. Brilliant that we have Grace Fu here. She's from DeltaQ. She knows this stuff. So what I'm going to do is, without further ado, is I'm going to pass you on to Grace. She's going to take over and take us through the next hour. We have put you all on mute just to make it nice and easy, obviously, for the presentation. If partway through you have a question, raise your hand. And if we have time, we might be able to go through them at the end. We'll try and allow, if we can, 10 minutes at the end just to close up and any final questions. But without further ado, Grace, I'll let you take over.
Thank you, Quentin. I'm just trying to make sure I can share screen with all of you. Let me just try to see. Quentin, did that work? Okay, let's try this again. All right. Well, thank you, Quentin, for the very generous introduction. My name is Grace, and as Quentin mentioned, I am from DeltaQ. I will be presenting to you the findings from a research project that we worked on behalf of the Department of Industry, Science, Energy and Resources. I shall call them DISA from hands-on, just so that it's less wordy. And basically what we're looking at was what the impact of a changing climate had on building design and energy. So I'll be walking you through some of our major findings. Clearly, we've only got, about 45 minutes or so. And so I won't be able to go through all the detail. If you're interested in more detail, the report is published online. And you can also feel free to ask me the question or pop me an email after that, and I'll try to answer it. Key to this, though, the main reason why we're holding this webinar is because the department has also engaged us to help them do some primary research. So some of the findings in our initial report were done based off a very small project team. I'll introduce you to who they were later on. And we wanted to validate some of the statements that were in there before we move it forward. So you would have received in your email a survey for you to complete, but also throughout today, what I'll be doing is polling you using the platform Slido. So if you could please just join in on your phone, web browser, or if you had your phone, instead of going to slido.com, you could also just scan the QR code. And you'll bring you to our platform. And when we're polling you with the questions, you'll be able to see the answers come up on the screen to see what your peers in industry are doing. And it will all be anonymous, so don't worry too much about it. If you've got any issues in terms of technical difficulties, please feel free to post it in the chat. Or my colleague, Tim Lesky, who's also from DeltaQ, will also help you out. So today's agenda is mainly for me to present my findings from the report. As a commercial organization, we are working within a scope, and therefore I will also let you know what some report limitations were. I'll quickly run through what the methodology we employed were, the climate files that we used for the purposes of this study, and go through the headlines findings. And as I mentioned, you are the modeling experts, and we want your feedback so we can actually use that to influence government policy. So let's step back a little bit and figure out what the context of this project was set within. I like to call it, "Why should I care?" And this quote here is actually taken from the co-chair of the IPCC, which stands for the Intergovernmental Panel on Climate Change. And it's basically the IPCC that has said that unless the world does something about human emissions quickly, and that's where our 50% reduction in emissions by 2030 and net zero emissions by 2050 activity and targets come from the IPCC. The world won't be able to keep its average temperatures below 4 degrees Celsius, or indeed 2 degrees Celsius. And as a result of that, we'll start incurring some climate impacts. Some of those climate change impacts include things like rising global sea levels. So you can see some islands and some countries are already starting to find themselves rapidly having to plan for their country going underwater. It also increases the likelihood of coral reefs disappearing completely. So instead of having 100% of them being lost, if you manage to keep our average temperature rise to 1.5 degrees Celsius, which is what the IPCC recommends at the moment, we're not going to see coral reefs anymore. Obviously, with climate change, we also not just see the average temperature of the world increase, but we also see extremes happening more. So you see more hailstorms, for example. Your winters might get much colder and your summers might get much hotter. So some examples like these. And in Australia, obviously, the bushfire season was a very strong reminder of the impacts of this. So this is the policy context for which the department had commissioned this work. And they wanted some evidence to provide and support some of the case that policy changes that they'll make to actually understand what the impact of this will be on building design, specifically looking at HVAC plant sizing and also your building fabric, as well as the energy modeling and thermal comfort. So the team that we pulled together to do this work was led by us, DeltaQ, but we had subject matter experts from Exemplary Energy Partners, who are Climate Files subject matter experts. They generate climate files. Northrop Consulting Engineers were the mechanical engineers as well as the energy modelers. And CSIRO also provided their time in the form of reviews and also provided some context around the work that they're doing for the Australian government and particularly for NAFIS. So CSIRO had just updated the climate files that's used in NAFIS. The climate files that we used in our actual work were only 3 sets of files. I would classify them as our baseline files, which is the ASHRAE IWEC files, which is based off weather data from 1982 to 1999. One of the reasons why we chose to use this file, even though it's quite old, is because it comes inbuilt in IES, which is quite a common platform simulation package that's used by the broader industry, and it's also free. With the future climate files, we used the ERSAT's climate files, which is prepared and developed by the Exemplary Energy Partners using projected change values from CSIRO, prepared by CSIRO for Australian context. Now, some of you who know a little bit more about climate files will see that the emissions scenario, which is the A1FI, is actually based off a 2007 IPCC report, as opposed to the newest report, which is the IPCC 2014 report, which starts referencing things like RCP 8.5, RCP 2.6. But the basis of it is similar. So the scenario for A1FI basically stands for the A1 is basically, is the estimate where it will get to 4 degrees Celsius average warming by 2100, which is the same as the projections for RCP 8.5, which is now the business as usual scenario, emission scenario. And FI just stands for fossil fuel intensive. So that means that there is no active policy and intervention to decarbonize our fuel sources. With the CSIRO future climate files, they also provided us with 2030 and 2050 files. I won't be going through them in my presentation today, but with CSIRO, we were only allowed to use it to compare and basically QA the purchase climate files, ERSET climate files, to make sure that both climate files were roughly aligned. So we're not using something that was out of the water. If you wanted to find out more about the ERSAT's file, I've just put a link there that you can look up more detail about how it was generated. So the research questions and methodology that we went through for our project was we did a literature review to try to understand what was done by our peers internationally. So today I'll quickly run through what they do in the US and what they do in the UK within the context of building code. Then we also did a climate files analysis between the baseline files, 2030 and 2050 files that I just told you what they were. Really, all this work was done in spreadsheets, and the spreadsheet work is then reported in a report that is published. We looked at the impacts on using different climate files on HVAC plant sizing. And for this, the ACAS BSG Camel load estimation software was used because that is the most common HVAC plant sizing software. And finally, with energy and thermal comfort modeling, we use Design Builder Energy Plus. Again, that is something that's quite commonly used in industry. We took all of those findings and analysis and synthesized them, really to answer 2 questions. One, is there a problem? And if there is a problem, what is the problem? And secondly, was to try to better understand how using different climate files might impact design features, at least on paper. And ultimately, in order to influence change in policy, we had to then bring it back to within the Australian context, which is our National Construction Code, Section J, looking at both the deemed to satisfy provisions, the verification methods, as well as the performance requirements, JP1, to identify on a high level basis what might need to be changed. Just quickly on the limitations, they were only conducted in 3 climate zones. So we did that in Sydney, Brisbane, and Melbourne in terms of our modelling and analysis, partly because, again, this is a piece of commercial work, so there's always scope limitations, but these cities also represent the most densely populated populations. Our findings are based on the specific climate file types. Now, we know from the survey that some of you use RMI files, TMY files, TRY files. We can't necessarily apply the same results to those ones there. So these are only specific to the ones that we modeled. The modeling in terms of energy modeling, HVAC plant sizing, and thermal comfort modeling were all based on the 2050 ERSAT's future climate file. The reason why we used 2050 was because we wanted to represent the worst case emissions scenario. And you'll see in our report, and as at the end, that we have recommended the department investigate or repeat the same process using a 2030 file. In terms of our analysis, we did hold our greenhouse gas emissions for electricity and gas constant, which means that we would use the same emissions factors for today versus 2050. Clearly, that's not going to be the case in reality. So we have also recommended the department look at what the impacts might be and what the results are if we change the emissions factor to reflect the current trajectory of a decarbonizing electricity grid. So quickly moving into climate files analysis now. what were our key findings? So what you can see here is in different colors representing the different states or different cities, should I say. And just to get your mind working, we're moving from baseline on the right side to 2050 on the left side. Okay, so we've done baseline, 2030, and then 2050 in terms of analysis. We care about dry bulb because we know dry bulb temperature affects sensible load. And therefore, this is a statistical distribution of our climate files. Okay, we also looked at wet bulb temperature and how it changed because that affects our latent loads, which affect our air conditioning system, particularly with cooling. What we saw was that with dry bulb temperature and wet bulb temperature, if you look at the lines on the actual box and whiskers plot, as well as the crosses, those represent your mean and your median. So that's the average dry bulb temperature and average wet bulb temperature increases as we go from today's climate to 2050. And that is observed across all climate zones. The other thing of interest is looking at the extremities. So you can see that we've circled Sydney and Melbourne, that the max temperatures and the min temperatures actually increase as well as we move towards 2050. And that tends to affect our HVAC plant design, which is sized based on our, peak design loads. We also looked at wind speed. Again, this is just an average wind speed because wind, we know, influences building energy consumption through infiltration and exfiltration, through some of the surface heat transmissions. It may impact our mechanical systems efficiency and whatnot. So on the whole, we see that it doesn't change that much. What we see is that in Brisbane, we do see sort of like a very shallow increase in average wind speed. Or really, sorry, these are instantaneous, so these are hourly wind speeds. But in Sydney and Melbourne, we see a slightly decreasing wind speed, which may actually be one of the reasons why we see warmer temperatures as well, because there is no wind to take away sort of that heat, should I call it. On an average, when we look at the mean and the median, we also see that in Brisbane, there is still that slight increase in wind speed, similar in Sydney, but in Melbourne, we actually see a decrease overall. Okay, so in Melbourne, we see a decrease on your maxes, but you also see a decrease on your average. Then we summarize them into heating degree days and cooling degree days. And the whole reason of that is because as the number of heating degree days increases, then heating energy, therefore our boilers, our heat pumps increases, our electric duct heaters. And then with cooling degree days, as the number of CDD increases, of course, our cooling energy increases. So what we saw here using a base of 18 degrees Celsius for heating degree days was in Brisbane, Sydney, and Melbourne. Now we're looking from left to right, it's baseline to 2050 to the right side. There is a decrease, a substantial decrease in heating degree days. And on CDD, with a base of 21 degrees Celsius, a significant increase in CDD. Okay, so those were our major findings. I don't think any of that was surprising, but it was good to see that validated through actual analysis and numbers. So I'm just going to move into a quick poll. If you could just log on to slido.com if you're not already there, or scan the QR code on your phone, or again, on your phone, go to a browser and type in slido.com. There is a poll for you regarding future climate files. And as you pop in your answers there, the results will start popping up on the screen so you can see anonymously what the rest of industry is doing. So I'll just leave this open for a minute or two, just for you to put your responses through. So when you finish clicking through the poll, don't forget to click send so that your results can get reflected. So we've got some early responses come in now. It's good to see that we've got lots of, should I call you blue states, New South Wales. We have quite a few from Victoria, from Queensland, Adelaide, New Zealand will come. Okay. Got someone from Canberra. I'm based in Canberra myself, climate zone 7. Okay, well, let's start looking at some of your responses. I know some of you, hopefully all of you are still typing your responses. If you don't see your responses here, we will be captured ultimately. So what proportion of your Australian building energy and thermal modelling work is carried out using future climate files? A good more than half of you actually never carry out using future climate files, and the rest of you is less than 25%. But there is a small proportion that have actually used future climate files, and a few of you who are based internationally, or perhaps you are not in the commercial sector, therefore haven't modelled Australian buildings. Okay, so for the times that you haven't used future files, why haven't you? For most of you, it's because there were no client requests. Interestingly, and not surprisingly, inadequate budget is a big one. Another one of interest is actually don't know what future climate files to use. So some of you might be quite happy with some of the recommendations that were made that the government is quite interested in. Hasn't crossed your mind, and so far there's been no opinions that there is no value in using future climate files. Okay, would you classify the buildings that you've modelled using future climate files as premium? Yes, I think that would be the perception right now, that only premium grade buildings that likely have sustainability targets would be modelled using future climate files. But I'm quite glad to see that there are some low tier or mid tier buildings that are also using future climate files. Not quite sure why, but that's a great outcome. Well, thank you everyone for participating in that. All of your responses are collected anonymously, and they are actually going back into a report back to the government, which then dictates the next, I guess, set of work and policy direction for them. So coming back to the presentation, we also looked at the impacts of using a future climate file on HVAC plant sizing. As I mentioned before, the software Camel was used, and I would say for those of you that are not quite aware, the design day, or should I say your design temperatures drive up on web updates. Sometimes you see in your ERA handbook or the DA09, ERA DA09, which is the heat load estimation manual, if I'm not mistaken, with the title. But basically, it says that out of 10 years of weather data, so 10 sets of weather files for each location, statistical analysis is then done to establish what the dry bulb and wet bulb temperature is that is exceeded more than 10 days a year. And then for a summer design condition, the 3 p.m. temperature is taken. For a winter design condition, then it's taken at 8 a.m. The main takeaway from this is that in table 4, you can see that I've actually marked up the design temperature difference between using a 2050 file versus the baseline file in Camel, which is actually based off 1990 to 2012 data. Is about a 2.6 degrees Celsius. Well, actually ranges between, on dry bulb, it ranges between 2.6 and 4.4, depending on location. And then on wet bulb temperature, it ranges between 0.3 degrees Celsius increase versus up to about 2.4 degrees Celsius. And then on the heating design temperature, it roughly sits around sort of the 3 degrees mark increase. But the main takeaway is that all of these design temperatures have increased, which means that if you were to use a future climate file to size, or weather data to size your HVAC plant, you would really be using a larger HVAC plant capacity. So what we then did was using the Camel software, try to determine what the actual chiller, boiler, and air handling plant requirements were. And we did that for 2 sets of buildings, one representing daytime only operations, so that's our standard office building, and then one representing a building that operates 24/7, so that's where your overnight temperatures actually impact operation at the hotel. The main takeaway from this is that our chiller size or cooling capacity required roughly increases by between, call it 10 to 20%. Okay. In hotels, we see that climate zone 5, which is sort of your Sydney in this case, because that's what we modeled, increases by up to 24%. Boiler size or heating capacity reduces by about 20%. And then with total airflow, so that's where your air handling plants, your ductwork risers, increase by between 5 to 10%. What we also looked at using Camel, and we recognize that Camel is not an energy modeling software because there's a lot of, I guess, simplifications that it made, but just to give us an idea of what change would be required in our building fabric performance in order to retain our same HVAC plant size, to still maintain the same capacity without changing it. And what this Camel exercise found was that in order to retain the same HVAC plant size in 2050, we would need to improve, when I say improve, I mean reduce our window U values, our glass SHGC, solar heat gain coefficient, our walls U value and roof use values. So we need to decrease them by between 40 to 50%, so improve double the performance in an office building or daytime only building. And roughly similar for hotel, except for window U value, which becomes increasingly important in an overnight building. So that's significant because it tells us that just using a different climate file or considering what a future climate looks like would change our HVAC plant sizing significantly. Now, we're not going to talk about current practice around oversizing and redundancy in this webinar, but we recognize that some of those may be absorbed within those sort of redundancy practices. The literature review that we did, as I said, we looked at the US and the UK, was mainly to help us understand if there was anything we could adapt for application within the Australian context. So looking at how California does it, because in the US it's regulated on a state-by-state basis, The way they do it is not to require future climate files to be modeled, but they update their baseline or the climate files that are used for code compliance regularly, okay? So they don't end up in a situation where they're still having weather files that are, climate files that are based off the 1980s only. There is some sort of renewal cycle associated with that. And of course, there is the ASHRAE climatic data for building design standards that governs all of that. With those files, it's embedded into software that they use for compliance. So unlike Australia, where you can pretty much use any software that has the capabilities in specification JBB, there's only sort of two software that is largely used for compliance in the US, and then those files are embedded in it. So sort of similar to what we do with Nethers here. In London, it's a little bit different. They don't provide you with a simulation software package. What they do, though, is they have CBCA, who is an industry body, be a centralized repository of climate files. And that central CBCA basically provides weather data and weather files for different scenarios, including the 2020s, 2050s, 2080s, different emissions pathways. And then they not only have that for, I guess, general energy modeling, but also for overheating analysis. So sort of more extreme type weather data. One other thing that is interesting, I guess it's talked about in our report, but I won't go through in our presentation here, is the CBCA files have urban, semi-urban, and rural files as well. And that's just to reflect the fact that in high density areas with lots of buildings, it accounts for some of the impacts of urban heat island effects. So that's quite interesting, seeing our two international counterparts and how they deal with it. Looking back domestically, we know that CSIRO does a lot of work around preparing gridded data sets for projected science change values. There's also a lot of work done by the state governments to provide future climate data. Just for general public to assess what the impacts might be. Now, the issue with those are that even though they exist, they're not in a format that's suitable for modeling. So they're not in the hourly, sort of the 8,760 hours per year type format. It's often in daily format, or you just be able to see it on an annual basis. So our takeaway from that was there was no suitable source at the moment that's ready to just roll out to industry. Looking at the climate file shortlist, quickly looking at, we'll go through in detail, but we use the exemplary energy partners files, they are weather files supplier. The CSIRO is currently doing some work for Nethers and updating climate files, but it's not open to general public. In the UK, they have those climate files, but it's not suitable for Australian context because it's only for the UK. The only option is, of course, for modelers to seek out things like, CC-Wool, WeatherGen, WeatherShift, quite popular, Meteonom, urban weather generators. Some of those free, some of those not free. But in general, there's no consensus on what is endorsed for usage in Australia, what is suitable. And what would be, what the differences between them are. So another quick poll for you, just looking at your practices in terms of doing using historical climate files. If you could just log on to slido.com, the new poll should have popped up. And as you answer them, the answers will pop up. So you can see the results of what your peers in industry are doing. Okay. So I'll just wait for the number of responses to increase to maybe about the 30 responses mark. And then I'll move through the rest of the questions. Okay. So you see lots of people that use IES and Design Builder, Energy Plus. Some use MATLAB, that's actually quite interesting. Ladybug, Honeybee, Camel for energy and thermal comfort modeling, that's interesting. PHPP, okay. Did the historical weather file that you use come with the software package, or did you have to purchase it or find your own weather file? So most of you, 65% of you have it inbuilt. Some of you download it for free from other sources, purchased from weather file supplier. It's about just under a third of you have purchased it from weather file supplier. And none of the above. It would be really interesting for those that said none of the above, if you wanted to just pop through your comments in the chat panel, just to let us know how you got your weather file. That would be great. Thank you. Okay, a lot of you use TMY files. Actually, a lot of you also use IWEC, and actually that's not surprising because I know with IES, it comes prepackaged with IWEC, some RMI files, and TRY. We also have some that do use the second iteration of the IWAC files based off more recent data. And some of you have no idea, so you probably just run your simulation as long as you find the right weather station. Okay, this is all really, really good and insightful. Now, this particular slide is not going to be found in the report because I generated it very quickly after seeing some of your initial survey responses that some of you have completed. So thank you very much for it. What I thought I would do is to quickly show you, and actually, sorry, when I say I have to thank my colleague Hong Sang Zhang, who used IES to quickly run through the different climate files that we obtained from one building, as well as some pre-purchased IWAC 2 files and those that came inbuilt in IES. What I want to show is from the left side, which is the IWEC file. That's what I call it baseline. And then as we move towards the right, this sort of represents weather files that are getting more and more recent. I'm using that term relatively loosely. The TMY files are generally not, I guess, Australian specific. They're not developed domestically. The RMY files are the ones that are based off the TMY methodology in terms of how they generate weather files, but within sort of the Australian context with specific weightings. And we can see that as they get newer, we do actually start seeing increase. So that's the blue bars, increase in cooling energy or chillers energy, and a decrease in heating energy or boilers. In this case, they are gas boilers. And these represent energy, not greenhouse gas emissions. So the orange and blue are energy, which actually agrees with what our findings were in the report using Camel. I am generally not a huge fan of TRY files, partly because of the methodology they've used and the age. But as you can see there, TRY probably sits up the front in terms of age, but there's also some differences in it. So look, the takeaway from this is probably that when we're talking about availability and what they mean to industry and which ones industry should use, there's probably more guidance that should be provided, given that there are some variations in the climate files. So now I'm just going to do a quick poll for you to tell us what your thoughts are on climate files availability. So your Slido interface should have updated now to show you the new sets of questions. So once again, I'll just wait for the responses to come through before I start moving through the answers to show you what your peers in industry thoughts are. Thank you. Seeing more responses come through. To apologize for the number of questions that we're asking, but it is very insightful for us in the government, and hopefully you find these results insightful for yourself too. Okay, so for those of you that have said, well, actually, we know from the earlier polls that most of you don't use, haven't had to use future climate files for your projects. But for those of you that do, we see that large numbers of people use WeatherShift. I suspect that's because it is a free platform, and all you need to do is put in your EPW files and select a few scenarios, and it comes up with the answer or the updated file, future climate file. Some people that use Metronome, which is an online platform that you can purchase files from. Exemplary Energy Partners, who is a weather file supplier. And then none of the above. I think once again, if you use none of the above, it would be great if you either completed the survey, which would then prompt you on, who your supplier is, which will be helpful for us. Or you can pop in the chat box as well. That's just as useful. Thanks. Okay, so next question, what are the biggest drivers behind your use of future climate files in your Australian building energy and thermal comfort modelling work? A lot of you is driven by personal commitment and the fact that it's industry or international best practice, which is great. We can see that there are some clients that do drive the use of future climate files. Green Star is a big reason why, as well as neighbours commitment agreement. And then again, there's some that say none of the above. Would be great to find out more about that, either through you doing the exact survey or just popping in a chat box. Would it be beneficial for an Australian-specific climate files repository that's curated by a national body be developed? Yes, but only if it's free. That's more than half of you. The rest of you think yes, don't really mind. None of you say no, that's good. And it looks like $300 to $500 for most of you. Just over half of you think that's reasonable. Some of you think is expensive. None of you think it's cheap. That's a very good option to pick. For time period, roughly aligns to 16 to 30 years. For me, that's about the lifetime of your HVAC system, more than 30 years. And some of you think 0 to 15 years. Okay, for time period for HVAC plant design, yep, 0 to 15 years, that's your life cycle. Sorry, just there you go. Okay, well, thank you for your responses. So again, quickly, we're going to wrap up soon, but I'm going to run through to you what our energy and thermal modeling results were. So when we use Design Builder to simulate the differences between using a future climate file versus a baseline climate file, so remember future is 2050 in this context, We found that in an office building, if we were to size our HVAC plant appropriately, our heating energy, when I say appropriately, I mean that we've used the future climate file to size the HVAC plant rather than using our baseline climate file. So we see that heating energy decreases in terms of its, heating greenhouse gas emissions decreases by close to 80 to 90%. In the office daytime building, cooling energy increases, cooling emissions, should I say, increases. Same thing for fans and pumps, just slightly. And then we can see that heating and cooling emissions sort of balance themselves out. And when we look at the building as a whole in terms of total, we see the net increase in greenhouse gas emissions at about 10%. Not so uniform in our overnight building. We still see the same trends, but we see that cooling energy increases sort of double what it is now. We also tested a scenario to say, well, what if we simulated what happens now, which is you don't size your HVAC plant using a future climate file. Let's say it's sized for current. What would it look like in the future? Well, actually, from a building greenhouse gas emissions perspective, I see a decrease in greenhouse gas emissions in Brisbane and slight increases about that 10% mark, which is comparable to what we saw previously for Sydney and Melbourne. But don't be too happy yet, because we can see that the percentage of time that thermal comfort is achieved decreases if we try to use a baseline HVAC plant to service a future building. I want to caveat that these PMV values are taken off current DTS requirements, or not DTS requirements, the Section J requirements, which is plus and minus 1 degree Celsius. Okay, then with a hotel building, overnight building, we actually see a massive decrease in energy consumption in Sydney and Melbourne. We see slight increases in greenhouse gas emissions because we're transitioning from a gas-based heating to higher increased electricity-based cooling. But again, the same conclusion is that thermal comfort is significantly affected when we use those criteria I just talked about. We also looked at JV3 because that's what most modelers spend their life doing. With JV3, you would know that the context is trying to compare your proposed design to your reference design. And if your proposed design has greenhouse gas emissions that are lower compared to your reference, and you have occupant thermal comfort of PMV plus or minus 1, 98% of the time in 95% of the zones is achieved, then you comply. And what we saw here is, in summary, using baseline climate files, trying to trade off or reduce performance of solar heat gain coefficient of your glazing won't pass. So it doesn't comply. And even if you use a future climate file, the same outcome is achieved, which means that it doesn't comply. And what we're trying to say here to government was to say, well, if you're talking purely about JV3 and whether or not the design decision changes, in both scenarios, it doesn't matter the climate file that you use, you won't be able to trade off your solar heat gain coefficient of your building fabric. Now, there were other scenarios where we looked at trading off U values, and there was another scenario that we looked at as well. Those are in the report. But generally what we found was that design decisions don't change, partly because of the thermal comfort criteria. So the current PMV criteria, which is absolute, so you're not actually doing a comparison between your proposed design and your reference design, is the reason why design decisions don't change, because they just don't comply if you trade those performances off. So very quickly, before I wrap up to the key recommendations that we made, is from your initial survey responses so far that was done through IBPSA, please do complete them after this webinar if you could. Some of the questions will be similar to those polled today, some have more detail, but most of you strongly disagree that it's common to use future climate files, and a lot of you thought you require more guidance on what type of future climate files to use. And a lot of you also thought that the National Construction Code, this is actually Neighbours Commitment Agreement, National Construction Code, should require an off-axis simulation with future climate files. Okay, so all that work that was done, one of the key items that we saw when we linked all our analysis and findings back to the National Construction Code Section J was JP1, which is our performance requirement, currently doesn't reference a full lifespan of the buildings and its systems, such as HVAC systems and the building fabric, for example, and that needs to be updated. We did say with the second one that there should be a requirement that's introduced to use a future climate file. Now, there were a few things that we thought about. One was whether you use multiple climate files to model separate models and then present the findings. Or we also actually said to the government that they could actually use something like what the US does, which is update the files regularly and provide it to industry to use. And it was thought that using a future climate file, particularly 2030, which is close enough, would probably be the best, just because there's only one model that needs to be done. Clearly, because the verification methods include JV1 and JV2, which is the Neighbours Commitment Agreement and Green Star method introduced in 2019, those need to be aligned as well. All of the deemed to satisfy requirements need to be reviewed. And back in the day when the revisions were made, there was no assessment of thermal comfort. What we found from our work here was that some of the deemed to satisfy buildings or reference models didn't meet the thermal comfort criterion in itself. So whatever review and updates that are done, they really should be considering thermal comfort. Item 4 is the key one that will probably move ahead, and there's a lot of interest in it, which is to have that centrally available database of accredited and carefully curated climate files so that industry knows what to use. It takes the, I guess, wonder and confusion out of selecting climate files if you know that someone you trust, hopefully, has actually, and experts, climate files experts have actually reviewed that. And then there's a few other things, of course, around R&D for climate files that don't already have weather stations in urban areas, having to repeat some of these analyses using updated greenhouse gas coefficients. And one key thing that might not fall under Section J, which is energy efficiency, they may need to create a resilience section in the National Construction Code just to cover off the risk assessment for extreme weather events, which is not sort of covered under the scope of work. So that's pretty much it. I will finish off here. There is another item on Slido that should pop up. You can do it. But Quentin, you're welcome to, I guess, close this off.
Oh, thank you, Grace. That was really, really interesting. Interesting to see all the results, and I think it's very clear that we have a need for these files, and that I think it's fair to pay for them. Look, thank you all for attending. If the presentation comes up on the screen, that'd be good. There you go. I will just get to the quick next pages just to remind you. Look, we run all sorts of events. A lot of them are online at the moment, nice and easy. If anyone's interested in speaking, if you want to host, if you want to get involved, just talk to me, talk to anybody who's involved in IBPSA, and we can make that happen in the various locations. Don't forget, if you are a Green Star accredited professional, you can get a CPD point from the Green Building Council. Just search future climate files and that will pop up, so you can get your valuable CPD points. But otherwise, I really appreciate that, Grace. Thank you. You rushed through a lot of content, and I like these Slido, very handy. Grace, are we able to share the slides? I know that had commercial and confidence, but are you intending on sharing anything after this meeting?
I'm happy to share it if you would like me to.
Yeah, great.
All of it's in the report anyway, so
Yeah, I mean, if you could send me, what I'll do is if you send me what you're willing to share, I can put that up on the IBPSA website and people can download
Sure.
that. Perfect. Well, thank you all. I appreciate all your time and efforts. Have an awesome weekend, and keep in touch with IBPSA for future events. Thanks.
Thank you.